find that they were equal on both sides?
Yeah.
Yes, good. So we know that this follows the law of conservation of mass. How many people got 34 grams on each side? Good, good. Now, first I saw people just putting 2 and 6, and then you say, oh, it's balanced. So I've got 2 nitrogens on each side and 6 hydrogens, but we want to know the mass of them, so we have to multiply by their mass in the periodic table. Okay, let's go to our visualization. And I'm going to get my 2 different color highlighters. And we're going to draw this. Okay. Now, I want to keep my equation up here because we're going to draw N2 plus 3H2, and we're going to show that we can make 2 NH3s from that. Now, if you felt confused by this, or you didn't get it during your do now, or yours is incorrect, then you can follow along with us now and correct yours. Okay. So my nitrogen is going to be blue and my hydrogen is going to be orange. Now, how many N2s do we have in the balanced equation? You can just call it out. How many N2s do we have?
2.
How many N2s do we have?
1.
So we have 1, and that molecule has 2 nitrogens. So I want to show that these are bonded together. I have 2 nitrogens bonded together, but it's 1 molecule, 1 and 2. Okay, so if you do them separately, redraw them so that they're together. Now, how many H2s do we have? 3. Now, I know that's 6 hydrogens total, but every 2 are bonded together. So I have 3 H2s, so let's draw that. Each one of these is a hydrogen. And we're going to put these together in a container and they are going to react. They're going to bond with each other. Now our product is NH3. In NH3, I want 1 nitrogen bonded with 3 hydrogens. So I'm going to take one of my nitrogens from my reactants over here, and I'm going to bond them with 3 hydrogens. 1, 2, 3. Label NH3. Now, when I did this, I'm going to take the reactants and I'm going to cross them off. And I saw a lot of people not cross off their reactants when they made their products on your visualization from your homework. But we've used them. So I want to show that these now are gone. Because now they've made NH3, that they're not there in the reactants anymore. So if you didn't cross them off because now we can see what's left over to react. I'm sorry, did you have a question? Did you have to draw them like this?
Like the product, do we have to draw something?
You had to draw 1 nitrogen bonded to 3 hydrogens because this is NH3. So because that compound is 1 nitrogen for every 3 hydrogens, then it should look something like that. Yeah, yeah.
So, like, for our product, when you had, like, wrote it, what it reacts to, why in the visualization would we have 1 nitrogen there when in our coefficient has 2?
Right, so if we look at our reactants, are we done reacting? Can we make more NH3s from this? How many more NH3s can we make from our reactants? 1, right? I can take this N2 and bring it over and react it with my leftover 3 hydrogens. So that is my other NH3. Okay. And so we can see that from these reactants, we can make 2 NH3s. So I use these up, and now they are reacting. So that's what we mean by visualizing what's happening. So did we use all of our reactants? Yeah, right? We got all of them reacted. That now I don't have any excess. Okay. Now, next part, we're just going to look at container A. I think this threw you off because I gave you moles instead of grams, so you did something opposite of what we did before, but I was impressed by some people who figured it out. Now, let's go up here. In container A, we are going to do this reaction, but we are given a certain amount of N2 and a certain amount of H2. Now we want to know how much these weigh. Now this is giving you how many N2s that you have. So it's like saying you have 5 calculators. How much do they weigh together? Well, what do you need to know in order to figure out how much all those calculators weigh? If I say you have 5 calculators, how much do they weigh? What do you have to know, or what do you have to do to calculate the total weight of those calculators? Hands, people, hands. You have 5 calculators. What do you have to do, or what do you have to know about those calculators to find out how much they all weigh together? Sierra?
You need to know how much one weighs times 7.
Good. So let's say I tell you, well, each calculator weighs 10 grams. Well, how much do they all weigh together? You have 5 calculators. You know that each one weighs 10 grams. How much do they all weigh, Kenosha?
They weigh 50 grams.
How'd you know?
Because if one calculator is 10 grams, and you want to know how much is 5, you need to multiply the 1 by 5, which is 50.
So, we have 4 N2s. What do we need to do to find out how much those weigh? If I have 4 N2s, well, what do I need to do, or what do I need to know to figure out how much they all weigh together? Mia?
You gotta multiply
Y times 28. What do you do 28?
because one nitrogen is 14 grams, but it's, it's 14. It weighs 14, and then if you got 2 of them, then it's 28, so you got one.
So N2 is 2 nitrogens. We know from our periodic table that each nitrogen weighs 14. So I know that together, 14 times 2 weighs 28. So if I have 4 nitrogen at 28 grams apiece, how much do all these weigh together? Is this, put it in your calculator. Hands, Deja, 112 grams. Anybody else get this, 112? Good, okay. So let's go to moles of H2. We're gonna do the same thing. How much does H2 weigh? You can just call it out. 2. Each hydrogen weighs 1. Know that hydrogen weighs 1 is easy. So we have 2 grams apiece, and we have 6 of them. So how many grams of H2 do we have? 12 grams of H2. Now, I cannot use these numbers yet to help me figure out how much product we're going to make, how much N3 we're going to make. Okay? We have 4 of these, and we have 6 of these. And we want to know, well, how many of these NH3s can we make from that? Okay? Now, how many NH3s can I make from 1 N2? Look at your balanced equation. How many NH3s? Naeem, you with me? Look at your balanced equation. Look at your visual. How many NH3s can we make from 1 N2? Avery? Nope. Look at your coefficients. How many NH3s did we make from this guy? Miata? 2. So, from 4 of these, how much NH3 can we make? If I have 4 of these, and I can make 2 from every one, how many can I make, Greg? 8. I can make 8 moles of NH3. You're going to have to do this calculation to figure out how much we can make. Now let's look at our H2 to NH3s. Our equation was N2 plus 3H2 makes 2 NH3s. Now, every time I have 3 of these, how much product do we make? If I have 3 of these, how much product do we make? 2. So what if I have 6 of these? How much product would I make then? No. Look at your ratio. It's a 3 to 2 ratio. For every 3 of these, I make 2 of these. So now I want to know, well, if I have twice as many here, how much NH3 would I make? 4. Good. Okay, that's your like mental ratio. 4. If I have 3 for every 2, then if I have 6, I'm going to make 4. Okay. So I can make 4 NH3s here. Now let's look at our possibilities. I could make 4 NH3s or 8. How much can we really make? What do you think, Naima? How much can we really make? 4. Why the lowest? Why should it be 4 not 8? Naima! If I gave you 3 cars to a body and 4 tires, how many cars could you make? Do you have enough tires to make 3 cars? If I gave you 3 bodies and 4 tires, how many cars could you make?
You only need 2, no, you only need 1 car.
One.
Because you got 4 tires, and 4 tires go on 1 car.
Why didn't you say you could make 3?
So you don't have enough tires.
You don't have enough tires. Do we have enough N2 to make,
Oh,
do we have enough H2 to make 8 molds of this? No, I'm limited. I'm limited by my H2. I don't have enough, right? So I can only make 4 moles of this. Now, last part, if I have 4 moles of NH3, how much does this weigh? Look at your periodic table if you didn't do it the first time. Let me see a hand. Look at your periodic table. How much does NH3 weigh? We have 4 of them. That's how much we made. So figure out how much NH3 weighs. Look on your periodic table. Raise your hand when you got the answer. How much NH3? How much does each NH3 weigh? Hello, hello. How much does each NH3 weigh? Hassan? No? I've got NH3. I want to know how much 1 weighs. Now, you may have given me how much 4 weighs. I don't know. But I want to know how much 1 NH3 weighs. Niana? 17. How'd you get that?
because I know that, nitrogen, the reactants are 14, and hydrogen, the 3 of those, that's 3, that's massive.
Okay, good. So each NH3 weighs 17 grams. We have 4 of them, and maybe this is what you gave me. What was this answer? 4 times 17? 16. That was 68. So we made 68 grams of NH3. Okay, so that's container 1. Yeah. Let's not do container B or C yet. But let's look at the bottom. Oh, we should like freeze this or something. Can you all see this bottom row? Can you all in the back see this bottom row?
No.
Does everyone have this part down?
Yeah.
Okay. Then I'm gonna erase this. Also, you can probably stop it. Or you can keep